make a kata using TDD. There are two katas here. This is a supermarket kata. The first one is just for thinking. Is this kata is more for have the ability to abstract things on how like business rules can be like code. For example, this is the discounts or the rules for prices in a supermarket. Like so, like most of the products, I don't know, cost $1. But if you buy three, you can have them for $1. But what happens if you buy four or if you buy five? Or the ones that are priced by pounds or amounts of the product and not the quantity. Also, this kind of sentences like buy two and get the third one free. So does the third one has a price, or what happens if you buy four? How much does the last item cost? So this is for thinking how to do it. The second kata is the checkout. This is the actual code for calculating the price, the total price. This is the test that we want to pass. That if I don't buy anything, the total should be zero. If you want one thing of the total is 50, and so on. This method, what it does is transforms a string, like read the string and split the string like by character, and then add it to the scans the item to get the price, and then if they are not in order, like this one, for example, what happens if you buy 3 times the product A? It should have a discount, but what happens if you don't scan them in order? So this should be able to calculate the correct price. You shouldn't expect too much of this kata because I tried to do it before, but I couldn't. So I made a first attempt that didn't work. This is my second attempt, and I'm trying to make it work. So let's see. This is I'm using Kotlin because I'm learning Kotlin at the same time. And the idea is to have an app that is like a checkout program or app. The only thing that it does, well, it has I have the layout here. Well, it only has an input text or this edit text for scanning the product, this button for scan it, and the total price of the checkout. That's all the UI. And the basic usage of this. My computer is so slow. The basic usage is using a presenter. So create a presenter, and when we click the scan, we scan the input text and we expect the list of products. This is a nice to have feature. The real feature is have the total of the checkout here. This is the presenter. It's basic code because I made a test just for designing the presenter. That is you click on scan and you should get a show check method callback in the view.
I have a question. Is the function scan is similar to scan in C?
No, well, I think you missed the first things of the kata. You're like, this is like a barcode scanner. So you scan with a real barcode scanner. It types the ID of the product or the an identifier of the product, and then press enter, and it scans the product. Like this is like a supermarket checkout thing. So this scan method, what it does is scan a string, any string, and then it shows the check. Check out all the the product that you have scanned already. The idea is use TDD.
But this you did it
Already. Well, I just did the basic test. Like how are we going to use it? I did
but for this code, is it a sample or did you do it?
I did it like this morning. I tried to do it yesterday, but I couldn't. So let's see if I can make it work today. Well, this kata has some examples like this is like the rules for pricing. For example, you buy the prices are the A product costs price is 50, B is 30, C is 20, D is 15, but there are like discounts or special prices. Like if you buy three, the total is 130, and if you buy two, the total is 45. It's kind of tricky, I think so. But let's see how we can do it. So here we get some help because we already have the tests that we want to make them pass. So let's start doing the test. Yeah, and they're ordered like in the complexity also. The first one is like an empty test, an empty product list of products, just one product, two products, different products in different order, the same product several times, different products, and this is the most complex one. What's happened? Is it recording?
No.
Now it's recording.
Yes.
I think so. Okay. So this is the basic test for the presenter, just to design how it will work. Like you press scan and you get the results. But the actual code is not the presenter. What we are testing is this class checkout. This checkout class is the same that we have here. Like the basic design is you create a checkout object. You pass the pricing rules, scan items, and then get the total. That is the basic usage of the class. That's what the presenter will do, and then return the total. And these are the rules for this class. So let's start with that. The first thing is create a checkout test. Let's play first TDD. The three rules of TDD is like write a test before before writing any production code. The second rule, it's do not write any production code that hasn't been tested. That did not test. That haven't been tested. Sorry. And then you do not write a new test until you have all the tests in green. I should have read those rules. The idea is to write the test a little bit ahead of the production code. And start writing the test, making them fail. A failure could be even that the code is not compiling. Yeah, you are not allowed to write any production code unless it has to make unless it is to make a failing unit test pass. So you cannot have production code that is not for a failing unit test. The second one is you do not write more than a unit test at a time. You don't write like all the unit tests before. You just write like enough of each unit test to make the file, and compilation failures as failures. So this is the first things to make it work, like creating the class. Here I create the class, but it does nothing. Next one is you are not to write any more production code that is sufficient to pass one failed unit test. So here I don't even have a test, it's just creating, like setting up the object that we are testing. So let's start. This is Kotlin, and what we can test here, we can separate this test.
All you were talking about those cases. The first one were the base cases or something. They talked about the second section, and you stopped in the third section, and you were saying something like the most difficult one is
This one, because it could be easy if you were counting, for example, the rule that if you buy one product, costs 50 pesos or 50 something. If you buy two products, the price is 100. But if you buy three products, the price is 130. And this is kind of easy because you could like go in counting. If you, as the next one is the same as the previous one, well, you can count them and then see if you have to zoom like 150 or zoom just 30. But what happens if the products are not in order? You get first the A, then the A, then the B. You can count, and you don't know how many products will come in which order. So this is the most tricky one. So let's start. Also, testing. It's like, well, the theory is that you only have one assert per test because that makes clear what this test is doing or is documented. So let's start with this, an empty product of list. So test empty empty items. And here the tests are passing. Let me from JUnit package unit test. So this will run the presenter test and the checkout test. They passed. So the first rule is you start green, then you make a test phase that is checkout, scan. No, you don't scan. You scan nothing because this is an empty list of products. So you just assert that assert equals zero and checkout total. I think this will pass because I already write that code just to make it compile. Yeah, my bad. The rules. No, it didn't. Yeah, because here I pass an integer, and this should be a float.
With command error?
Yeah. My bad.
You can install a plugin that shows you.
Big. so you don't click anymore.
That's
Okay, yeah, this is my bad. I use it for the second test. This one. Well, there was a test already here, so
Just a doubt with copy. Why the variables are underlined? Yes, this guy something related to copy.
like this variable,
Yeah, why
this is
underlined?
a field variable.
Why the field are this field is underlined?
I don't know, it's just the style of the
Okay,
ID.
it's not. Okay, the next test.
That's it, yeah. That's this.
true.
We're going to test. This is like one product, one item. So assert equals, we should get 50 when we scan A. Check out total and check out scan A and 50 FJs. Yeah, I was thinking if we should write this kind of function to make it easier. I don't know.
What is the
Well, this
you
like read this string and execute scan function like many times as the characters here. But let's start copy pasting and then if we see that it's too much, we create the function. So we run this controller.
fast?
That will be too bad. So here we are designing this. So the easiest way to make this test pass is like going into scan and simply return 50th. And now here, no, it's here. Sorry. So this will make this
Did we make fake?
the other one. Yeah, it's kind of the same thing. Like you are designing how to make this code work.
Actually, it won't because the other one we didn't do a scan. Yeah.
Yeah, it doesn't matter. We expect here 0 and then 50 and
Yeah.
here 50.
We've always did it.
So the other easiest way to scan something is like, hey, where I can get these prices. So I can put an if, basic if product equals, here is not equals, here is equals A, store the price, like total is 50, and we create this current total.
When current.
Because there is a function here in Kotlin, functions and variables share identifiers. So this goes here.
I
Here
don't
is
like
0.
the name current.
Could be total so far. And then here.
It's weird because total is total.
So
Okay, yeah, but I think I'm
we could rename this like final total. Then here,
Subtotal and total.
subtotal, yeah.
okay, so total. No, but this is something that's good. Like TDD helps you to design how even the method names will be. Like you are discovering this now in the first line of your code, not until you write 100 tests and you have to refactor everything.
But
So-
actually, it's not subtotal, it's total. Because it's the total.
Yeah, at any point is the total, but what is the
You
difference?
can call it total price.
What we could do is this. Yeah, now I get it. We could remove this, rename this for total, then add together,
The total.
and then, well, basically it's total, and that's all. And we remove this and this. Oh,
You made it public?
sorry?
I don't like public things like
But what does it mean public
that. You should have a girl.
and private? What does it mean private and public? Are private from
Private, you
who?
can't access it directly.
Or
The girl.
yeah, and protected. What? Like you are protecting your variable from who?
From you.
That doesn't make sense. I know that this is private and
Well, anyway, that's we don't care.
yeah. So this makes the test pass. We know that this is working, and we could move now to the next test. Now we are testing two different items. So test two different items. Check out scan A, and then check out scan C, and then so equals it should be 80. Check out total. And
Because the code is very similar to what
yeah, Kotlin and Swift are
yes, it's
the same language, and it's also the same language as Scala, so don't worry. You are learning 3 languages at a time. So now it's failing. And now probably we could like start doing like else if B at 30, else if C at something. But probably it's better to start doing like these price rules, like how much does that product cost. So let's see if we could have like products and get like product or more like prices get product and it will be a price object, I think so, or what?
But instead of product, it will be A. What do you call it?
I think will be product.
Okay. I get it. Now I get it.
And then total
Cut it.
plus equal price, something like that. So here, let's create this variable. Val, yeah, it's like let.
Like what?
Let in Swift. String
It's
float. And this is map or hash map.
man.
Yeah. Yeah, they took it from JavaScript. We could save one line here instead of signing this.
No. You can.
We can put this. Yeah, because this, what happens here? By double long, not for flow. Why? Get.
Because you have to do the function.
This is the function. Get. I think this is missing. This string plot.
Maybe I'll enter. Suggestion.
Okay.
But there is this function for.
Maybe plus equals is not the same. Not in Kotlin.
But float defined in include. Let's. I don't know. Let's deal with Kotlin other time. Just put total equals total plus. Yeah, the thing is this get. I think so.
Yeah.
This get is returning
Two string.
B.
Can you make two float or something
I think so, but
at the end?
yeah, it's
Float.
maybe we could add here. Oh, like plus equals.
And there is a one.
Only save. Oh. Well, this will always have a.
Can you make a function?
Not
Because this is starting to be unrelevant.
Yeah, when you click add enter, you have an option. But
here because the plugin of Kotlin is not that intelligent.
no, let's say something that you make add enter. Create extension function. No.
But this is like this.
Now.
The thing is that this one, how it has to update this. Here, now it gets. Yeah, because in Java, the map interface could return a null if it doesn't find the product. That could happen here also. So we could check before, yeah. If prices contains key product, do this. If not, I don't know, do nothing. So let's see.
You don't have any. Where do you use this one?
Here in the check, in the test. So now it's actual because it didn't found any product. So let's create this. Let's pass these prices as a injection of the class and not as a variable. So here we move here. I forgot to put this here. So now we get it as a constructor parameter, and we can create that class here. Check out prices. It's a hash map. What is there?
You can use.
Time difference not enough to. Yeah, I have to tell it that this is string float. And now let's put the prices. Prices put like for product A is 50. Prices for product B is 30. It should be maybe. And those are floats. Now let's see.
You need to look at that.
Yeah, this go fast. Cool. Next test. It's like 4 different products. I think I can copy, paste. The four different items. This will be C and D, and the price should be 115.
Choose the CD.
Yeah. And 150.
Right.
Yeah. Okay. To make it fast, I think I can only just add the products to the prices. Prices are 20 and 15. C, D, 20, 15. I think it's time to factor. So let's create this price function. For creating that, fun, what is the name? Price? Yeah, price. Price. Or we do like scan several. This is string. Well, here's the products. Strings. String. What this will do, we'll check out. Well, we will iterate for product in products. Check out scan product. I should string. I don't know how to iterate. Let me search for that. Iterate string char by char. Kata. You could do it like a 4, like that. No. Here. No. That's what happens when you're trying to learn two things at the same time. Yeah, it's good. It's faster, but you have to like slow down things.
Trying to do your for each or something, right?
Yeah.
Type for each function.
For each string. Copy.
For just for each anything.
I don't know. I was already here, and I didn't like this.
But this is for each method.
So this says that I could do something like products for each. Here I can get an S, I think so. and then check out
Longer time.
exactly. Scan. Yes. Why? Ah.
Let's see the
Yeah.
nice.
This was a chart. So this calls everything. Now can here I will refactor into scan several DCPA.
The same string.
And we'll do magic. Working.
Which is the function that splits the string into chart?
The for each.
For each?
For
It's
each.
a for each in the
For
string.
each chart
No,
in the
it's
string.
character in the string. That is
Okay.
Yeah. And you can even do not need this function.
okay.
Yeah, I could do something like
I think it was better with a function.
do you?
Yes.
I like this.
I like it in a function, but here it's a bit.
Like abusing the syntax.
Yeah, I think it was better.
Now I like it that.
This is lovely.
No, it's not.
You will have to write that all the time.
You
The
will.
function is much easier. Scan DCBA.
This is already everything the same.
Bastards.
I think it's cool in a function, but like this is much clearer.
Okay.
You can never even remove scan several in call it scan.
Yeah. This was AV. So, and this was, that could be like that. So this is still passing. And we are short in time, so let's jump into the
The more
next,
difficult one.
the most complex one. Let's start with this one. There is 3 products at the same time, and try to code these kind of rules. So this will be test from 3 items, 3 items, 3 like equal items, or 3 same,
Three similar. No, equal.
3 equal items. Yeah.
Identical.
Identical. Yeah. Identical, I think so. Identical. Identical. Yeah.
Word, right?
Identical items. So this would be scan A and so equals. It will, I think it's 30. Yeah. 30.
Because
There is a discount. Yeah. Check out total. So this will be fail. And
can you test it pulling 50 to see?
well, it should work. I think so. Wait for it. Yeah, work. So this should be 30. So how do you think we should do it?
We should call a function.
So this was the idea of the first kata. Like, what does it mean? Like buying 3 for $1. Does it mean that each of these products the price is 30 cents, 33 cents, or
No,
should it mean?
it's like a model. Like if you have 3, it will be $1. But if you have 4, it will be $1, and the fourth will be full price.
And what is the full price? Or would be this one? Like
Yeah,
buy
this
2
one.
and get the third one free.
Yes,
What is the price of the third one?
0.
Like 0. And what happens if you buy 4?
Pay,
3.
pay 3.
No.
But this is something we just have to
Pay 3 and you
decide.
get 4.
Yeah, but
We have the supermarket, so we decided.
yeah, how do we decide? Like
Yeah.
the rule, the rule is simple: buy 2 and get the one free. So if
Every
you
2, you get 1.
and so
You can only buy multiples of 2. That's the rule.
If you buy 3, you get 1 free. No, if you buy 3, 1 is free.
yeah, let's try to code a rule that it's. So I don't know. You tell me one and let's see if it's easy or
But
it's.
which one? What we should decide? Which one do we want?
So
Because 3
I
for
think-
$1 and buy 2 and 2. I don't know. So,
Yes.
let's do it in 5 minutes so we can refactor the next 5 minutes to do it correctly.
we have 15 minutes left.
No, but we are missing the most complicated case that is the different orders and
Yes.
We want
I think that we have to continue storing the total, and while scanning any number of products of the same type, we have to make the discounts. I mean, it's like when you are in the supermarket and you scan 1, 2, the third one you see in the screen that is like 40, 80, 120, and then minus
The discount
40.
for each.
So we have to subtract each time that the number of products that we define it's scanned. So,
I like that solution. You?
making a sum and then a subtraction.
But at
Here we
the
go.
end of the sum or while it is being
Yeah,
done?
yeah.
Subtraction, I don't know. I don't know. Could be at the end or while scanning. I don't know.
So you mean
Maybe
like
while
something
scanning
like
it's
modulo
easier.
and every 2 we remove, right? Something like that? Or?
Like discount something, I think.
Yeah,
So.
every 2
every
Sounds
every
every
three,
two
every,
items,
we
you
remove.
discount the second one.
But
No,
what do
it's
we
every
want?
3
Do we want to
items.
buy 2 get 1 free?
No, I think
But
that
the rule
at
is
the
not
end
that.
It's better.
The rule here is different. Well, it's the same concept, but it's different. It's if you buy 3, you don't pay 100, you pay 130.
That's
So-
different.
But it's the
But
same.
this is only for product A.
Yeah, and you have another rule for product B, 2 for 45.
Yeah.
So,
So
but
it's
the
like-
idea is the same, I think so. You are counting and then you discount something.
Mhm.
The discount could be the full price of one product or could be a less than
Mm.
the
But the
price.
question is, can we do a generic method for this that will work for the 2?
We don't know yet. We are like doing it for the
So we're
A,
starting to do for only for A.
for A,
Okay,
and
let's do it for A.
let's see. So, if
Discount A or something.
here, like, if, and how do we, well, we have to keep counting how many A's has been in the sequence. So we have to count them. So
If
let's A counter plus 1. I think there is a plus 1. Well, if product equals A, we start the counter and then,
why is it right?
sorry?
You have to define
Of course, yeah.
counter equals 0.
Okay, the property counter 0
But it should be local.
should be local to the checkout, I think so.
Discount.
To the function?
This
No, because the
function-
function can be called several times.
Oh yeah.
And this is bar, sorry. Um,
What's the difference between that and that?
it's like you can change the value of a bar and you cannot change the value of a constant variable, basically. So counter of A, then if A counter is 3, then total minus
Minus the price of the
No.
20.
But this is very specific.
Yeah, we're getting to the second one. This is on purpose.
Because if you buy 6, it
Hmm.
doesn't work.
Well, let's make it work first, and then let's try to make it better. So I'm gonna run the test. This should.
But this is not gonna work.
This is gonna work.
It's gonna work until 3.
Yeah, it's gonna make
But
the
if you
test
buy
pass.
6, it doesn't work.
Yeah, let's write the test with 6. Here, now we have our test running. Now,
But is it now?
yeah, like this one, like this kind of items.
Yes.
Yeah, but the last one won't work. No. The last one.
Well, let's try with the last one. If you are so impatient for making it. Test. Font 6
Different type. It's
identical items. Scan 1, 2, 3, 4, 5, 6.
I like this notation. That it's like mathematical.
Like it names the name of the parameters.
the new
Kinda
thing
cool.
of,
But I think it's doing it in Java also.
yeah, I have it.
Yeah, in the
This is
new
IntelliJ.
IntelliJ. Yeah.
But it doesn't. It's well made because it doesn't do it all the time. It does it basically when it's not clear. Only when it's not clear. That's pretty good.
So this should be the result, isn't it?
Yeah.
Like you're buying 3, 130. You're buying 6, 106.
Okay.
Okay,
Now
it's not
what?
working. Now you're right. Now let's fix it. So
That's why we need to do a model.
we could do a module and make it work. So a contour module 3 equals 0. Let's count 20.
So it's buy 2, get 1 free, right?
Yeah.
So it means if you have 3.
Well, not buy 1 free. It's get
buy
20
3
of discount.
Yeah.
So this make it fast.
Yeah. I'm
Oh.
happy.
Now let's go with the next case. What happened if we have this one? Like A, you have 3 A's and 2 B's, but if you buy 2 B's, the price is 45 instead of 60.
So we
Yeah.
need to cut the.
So let's write the test. On and 3
But
A's
can I
and
say something?
2 B's.
Your test should be different. Because 3 identical items, this test is only going to work for A. If you put BBB, it's going to fail. Because B is not this price.
So 3 A's could be better.
Yes.
3,
6A. Well, A's. 8 items, yeah. 3 8 items. But that's okay. So
but I don't know. I don't know. Maybe because it's a general thing of testing.
what?
Yeah.
If you don't specify it's A, but you put as a condition that it's scanning the A, you need to size it in the title.
Yeah, it makes it clearer, more clear if it's in the title. So
But it makes it
Yeah, but also means that you have to spend more time maintaining the names
Because I
of the
think
test.
now 3A and 2B items is kind of
Well, let's continue with these names. We have 8 minutes to finish, so and then we refactor the names. So here will be scan 3A's and 2B's, and third equals. This should be 3A's to be 175. So it should fail. Cool. And now we could think how to do this.
Well, first we need to test B. We need to do.
Yeah, we have
product B.
we have a B test here, like
No, but not test it. But I mean, apply the discount for B. Code the discount for B.
yeah, that's what I'm going to do now. We could go like in the same way that we did it for A, but this it's not scaling for more than 2 or 3. So and it's hard coded into the checkout thing. So the idea should be to put it out. So how can we convert this code into a generic code? I'm thinking something like, hey, what happened if the price that we get here contains, instead of getting a float, we get a float and a rule for discounting. Like, okay, this will be float, this will be like price class, like price, and will be something like this. And then we say a total will be equal price cross price dot I don't know, price price something, and
Value.
or value, and here we could get like if price, I don't know, something like has discount,
The number 3 could be the number of products for a discount. Maybe for some other products, you need to buy more. But this is an
yeah, exactly. No, it's exactly what we're going to do. So this a counter is like attached to one product. So let's make it generic, like counter for
Or items.
yeah, items counter, whatever items of this product. Can you do this? Yeah, I think so. No, this is like items. Now here will be something like items put product items get product plus
No,
one.
where I
Here I'm like grouping like was a counter that was attached to a product and a specific product to add like a map of products and its counting items.
Okay.
The
Yeah, I get it.
items. So
So we can say there is 3R and 2B.
yeah. So here product will be A, and we get the product A. And here, if this is there is a something there's a if, yeah, it's like if items contains, we can refactor this into a function product. So we get this product and we sum 1, else we put just 1. Like,
Yeah, okay.
here I'm missing the parentheses.
Yeah. The refactor is
So let's start to refactor. So
just for me.
yeah, first start with the price, and let's create this class. Let's move it. Here. Now, let's create this variable. Price. This will be. No, I did wrong. Price, price, yeah. Price value. Create this property. No, not buy. This is floor. We don't need this. Then have a discount. Create this member function. Again. Yeah. Let's. I think we can refactor this into a member function. So, has discount. Let's put it like this. Then items put this, create property items. This is bar. This is map of string and prices. This is hash map. Yeah. Sorry, I'm almost finishing. Now I have this.
Because items, it's a map.
Yeah, and map has.
It's not add.
It's add. Oh, it's put.
So it might be the string price. Price is contains product price. Can you put a new line and write items products?
You can do it like this.
It's different.
Nice. So it will be even better. Item product equals. Now what is I'm missing. No.
It's not like this.
How do you use Kotlin map? This is so sad.
Okay.
Going here.
Map.
Read only map, no.
But the other.
No, yeah.
No, this is for reading, but for writing.
But accessing.
Yeah, but we want to write now.
Map
Should be here.
This is for reading.
No, this is for assigning a value.
but outside the
No, it's accessing.
Yeah. No, but value. It's assigning
okay, yeah.
the one that I'm selecting.
Or is it different?
Where is the problem with this? Could be this.
No.
Dice type, infer can infer type B.
So product is not a string. Is it?
I think the problem is this one. Price. Yeah, this was the problem.
But can you put map again?
Where?
No, come back. Up. Here.
Ah. No, I think map it's read only. So hash
It's
map
not
is
like Java.
no, it's not exactly like Java. It's well, let's do it this way and then figure out what is the why it is
Price, you have to do something.
So items and our items is not price. This is an integer. We are counting. We are not putting price. I made a mistake here. And now let's return our item. So if item contains product, it will get the product and someone. This is as in. There's one else one. And what is the problem with this? Here, I'm missing. So is this clear?
Not at all.
Okay, so let's change
I
it.
understand, but it's not.
I don't
Yeah,
like
at
that.
braces. Do at braces.
I don't like it
But-
because
I mean, we are doing a kata. We don't need to do.
Let's do it this way. Else, I think it would be readable. So here we are counting. Next, let me remove this counter. So items, product, module. I don't like this. Let's. There should be a better way to do this, but I don't know how to do it in Kotlin. So let's live with this now. Module 3 equals 0 and discounts. So now the discounts is something that comes in the price. So let's get the prices. I have the price. Not discount. I think so. Now this rule. Well, let me read this as a member. That could be here. Val discount. This is slow. This. What is the problem here? Yeah. This is Boolean. This is attached to the previous rule. So this could be a function.
actually the
So
tree
price,
could be another
you could like
parameter.
how do you say like when a product is valid for a discount, like I don't know, complain, not fulfill the rule, not accomplish.
What do you want to say?
Like if this number of items are able to like get a discount,
Okay.
it's
This price. But what is it? Why is this price?
what I'm trying to do is like let's see like is valid for a discount, and we pass the number
But it's not a price.
of
It's a number of items.
yeah, but how would you write that? Or price
Well, we should rename the price.
and
I
say
think we
like
should rename the
discount.
price class. The class should be well, whatever.
Or price
We don't-
can get a discount. That
But
could
it's
be.
not a price. It's an item. Or number.
But this is like a rule, price rule. This could be price rule. Yeah.
Take this from now because
Here
now
is a
7 minutes.
here's price rule. I think so. and then we refactor the other one. It's valid for a discount, for discount. Then we create this function that receives the number of items, and this is an int, returns a boolean, and here I think it's just an abstract class, because this one
Will be different
for each product. How do you make abstract? Yeah, for each product. Then it will, yeah, this will have an for us. I like to put that thing, but let's do it. So now we have this. Let's go to the test. Now our prices are not just like this. We have new price. I know here is like price. The value is 50F. Has a discount is true. The discount, it's a function that receives an int, like items. It's an int, and returns a boolean. It is true. This is 50F. Here is true. Yeah. And here it's a function. How did it? No, this is the discount. Discount is here is 20, and now here is something. How do we do this? I think instead of making it abstract, this should have like this val. This is valid for discount. Oh, sorry. This is a function. Receives a function that is this type. What I'm missing here is this one. How do you pass functions in Kotlin? Passing a function. Like this. Okay. So this would be val 2 points parameters t. Val points parameter would be int, like items, los puntos int, and the return would be boolean. Now, I'm getting it. Now our checkout class will be like here, and yeah, it's working. So here we just pass this function that items module 3 plus return. No, items module 3 equals 0. This should do the. How to make it? Come on. What is the problem? Ah, I see the problem now. I didn't change this one. Now it's working. This is an F. And this should work. So this is 30. This is 20. This is 15. And these do not have a discount. So I can pass here nothing. False. False. And here the rule for 2, it's for 2. And the discount is not 20, the discount is 15. Yeah, 15. So this should work. Price is price, and this one is not retrieving float anymore. This is price. So this should do the magic. Also, battery is dying. This is good because we are 15 minutes late.
Finish.
Yes, it worked. So let's just try the last case that is the most complex, and it should work. I think so. That is this one. This is 3 A's, 2 B's, only in 3 A's, 2 B, and 1 D, scramble. And this one is, and the result should be 119 F. And works. So the idea of TD is like a programming or writing code for making this pass like look like difficult or very difficult to write at the beginning, and doing like it started for the simple case like an empty list or a 1 product, 2 product, or 3 product of the same type or the identical product. It's easier to design and write code than that we could like test like this. And this could be refactored now, and we will be sure that any refactor that we do to this code, like to make it look better, make it work faster, make it like, I don't know, whatever refactor, readable or using less space in memory or something, will be working after the refactor. So we can be safe that any change that we do to this code is working because all the tests are passing. I think we finish.
Bravo.